This video will cover dimensional analysis. Dimensional analysis is a mathematical technique used to convert one kind of unit to another by using conversion factors. So this is really helpful when it comes to solving STEM questions involving measurements and conversions. So the steps of a dimensional analysis is the same. So first you're going to write your given, and then you're going to determine conversion factors, and you can have multiple conversion factors. Then you're going to complete your conversions. Then lastly, and if necessary, you're going to round your final answer to the same number of significant figures as the measurement with the least number of significant figures involved in the calculation. Okay, I'm going to go a little bit more in depth about sig figs later, but in general, for definition numbers, so like for example, 1 meter has 100 centimeters, that's a definition, so it wouldn't be counted as sig figs. But rounded numbers and given numbers, you should count that as sig figs. So yeah, I will go a little bit more in depth about sig figs later. But let's set up our dimensional analysis skeleton structure. So first, you're going to start off with your given, and then you're going to multiply them by your conversion factors. And multiple of conversion factors, then that will give you your answer. And make sure to put it in the correct sig figs if necessary. Okay. Our first example is to convert 60 milliliters to liters. So that's a really simple question. So we're going from milliliters to liters. Okay, and then we're going to write our conversions. So 1 liter is equal to 1,000 milliliter, and that is a definition, so it wouldn't be counted as sig figs. So let's start with our given. So 60 milliliters, so that's 3 sig figs multiplied to, remember, our bottom units have to cancel in order to get liters. So 1,000 milliliters over 1 liter, cancel the units, then we're going to have our answer in liters. So perform the operation on your calculator. You should get 0.0600 liters as your final answer. So it has 3 sig figs because our given value has 3 sig figs also. Okay. Our second question or example is to convert 20,012 centimeters into kilometers. So let's write what we have to go from. So we have centimeters. We can first convert that into meters and then lastly into kilometers. Okay, so let's write our conversions. 1 meter is equal to 100 centimeters, and 1 kilometer is equal to 1,000 meters. Now we can set up our dimensional analysis with our given. So 20012 centimeters. Bottom units cancel. So 100 centimeters over 1 meter, and that is a definite conversion, so no need sig figs for that. And 1,000 meters gives 1 kilometer. Perform that on your calculator and units cancel. We know that 20012 has 5 sig figs, and since these are definite, then we know that our answer is 0.20012 kilometers. Okay. Our third example is to convert 1.0356 times 10 to the power of 34 seconds to years. So this is more challenging, but let's first write our seconds to years. So we have seconds to minutes, minutes to hours, hours to days, days to years. And let's write our conversions. 1 minute has 60 seconds. 1 hour has 60 minutes. 1 day has 24 hours. 1 year has, this is a rounded value, so 365.25 days. So let's note that as 5 sig figs. And our given value has 5 sig figs also, so 5. And since these numbers are all definite numbers, we don't have to consider those sig figs. So let's start with our given. So 1.0356 times 10 to the power of 34 seconds. And I would assume the answer for this question is really big, so I would put it in scientific notation with 5 sig figs. So bottom units cancel, so 60 seconds to 1 minute. Okay. Times our bottom units cancel again, so 60 minutes to 1 hour. And then two more conversion factors. 24 hours cancel to 1 day. And then lastly, 365.25 day is 1 year. You can cancel your units and be left with year. Perform the operation on your calculator. You should get a number with 5 sig figs, so 3.2816 times 10 to the power of 26 years.